Everyone, I am Justine Rosel Banyes and I am going to report hydroelectric power. First, the objectives of this presentation are: describe the operation of underground power station, explain the factors to be considered in selecting a site. For a brief introduction, there are three types of hydropower facilities: impoundment, diversion, and pumped storage. In the United States, there are about 80,000 dams, of which only 2,400 produce power. This was because dams were used for other purposes like recreation, farm ponds, flood control, water supply, and irrigation, and then they later used it for hydropower. So for impoundment, it is the most common type of hydroelectric power plant. This facility uses a dam to store river water in a reservoir. Then the water released from this reservoir flows through a turbine, causing it to spin, which in turn activates a generator to produce electricity. The water may be released either to meet changing electricity needs or to maintain a constant reservoir level. Diversion, also known as run-off river channels, a portion of river through a canal or penstock. It may not require the use of a dam. Pump storage works like a battery, storing the electricity generated by other power sources like solar, wind, and nuclear for later use. When the demand for electricity is low, a pump storage facility stores energy by pumping water from a lower reservoir to an upper reservoir. And when there is high electricity demand, the water is released back to the lower reservoir and turns a turbine generating electricity. So for large hydropower, the Department of Energy defines large hydropower as facilities that have a capacity of more than 30 megawatts. For the small hydropower, it has a capacity to generate 10 megawatts or less of power. And for the micro hydropower, it has a capacity of up to 100 kilowatts. Micro or small hydroelectric power system can produce enough electricity for a home, farm, ranch, or village. So now let's talk about underground power station. An underground power station is a type of hydroelectric power station constructed by excavating the major components like machine hull, penstocks, and tail race from rock rather than the more common surface-based construction methods. After World War II, large hydroelectric power stations were placed underground, more often in order to protect them from airstrikes. Underground power stations form part of pumped storage hydroelectricity schemes whose basic function is to level load. They use cheap or surplus off-peak power to pump water from a lower lake to an upper lake. Then during peak periods, when electricity prices are often high, the power stations generate power from the water held in the upper lake. In recent years, there is an increased significance of underground power stations as a potential alternative in managing inexpensive electricity production in off-grid regions. Since they have low environmental impact, these underground hydropower projects are usually less capital intensive to construct and operate. Hence, they are developed on a medium to large scale and are widely used in flat regions to power industrial plants and meeting the needs of small communities. So, the underground hydropower plants are constructed below the level of water. These are low-head plants. This type of installation consists of a weir across the river to be harnessed and housing the power plants within the weir. The head race is connected to the tail race by a straight passage in which the tubular or bulb turbines operate. The turbine is connected to the generator by a horizontal or an inclined shaft, depending on convenience. So for the underground hydropower plant market, in various developing and developed regions, they are inclined to push toward the construction of underground hydropower plants due to the growing focus of renewable energy generation. The construction and operation of underground Hydropower plants offer several unique benefits, such as relatively less time required by the investors to regain their investment, low cost of energy generation, and the ability to adapt to varying supply requirements. In addition, the ease of regulatory requirements, ceding land, availability, and heightened security against attacks and earth slips are some of the crucial factors boosting the underground hydropower plants market. So these are some examples of the underground power stations. First, the Snoqualmie Falls Power Station in King County, Washington, United States. This was built in 1898 and was the world's first underground power station and is still used to provide power to the Seattle area. Next, the Robert Bourassa Generating Station. It is located in Quebec, Canada. It is the largest underground power station in the world. It generates 6,616 megawatts from 16 turbines with a net rated head of 137.2 meters. And lastly, the Kyra Pumped Storage Hydropower Plant, or also known as the Kyra PS HPP, was built in the Rila Mountains, about 100 kilometers southeast of Bulgaria's capital city, Sofia. Kyra has a generating capacity of 864 megawatts and the pumping capacity of 788 megawatts. The operation started in 1995, and at that time, Kyra was the largest pumped storage plant in Southeast Europe with the highest head in the world for a single-stage pump turbine. So, next to be discussed is the factors to be considered in site selection. The factors which are considered the most important are the availability of water, water storage, cost and type of land, and transportation facilities. So first, let's discuss the availability of water. Since water is the primary equipment of the hydroelectric power station, water availability must be in huge quantities. Such power plants must be built at a place where the water is available in huge amounts and at a good head as well. Next is the storage of water. There is a wide variation in water availability from rivers throughout the year. This makes it necessary to store the available water. In order to store water for constant generation of electrical power, we must build dams. In certain days of the year, the water quantity decreases up to a low level, which can affect the generation of electrical power as well. Third, the cost and type of land. Another most important point is the initial cost and type of land. The land on which the powerhouse is going to be built must be at a reasonable price, which it is also important to know the bearing capacity of the land. The ground should be good to withstand the weight of heavy type equipments. And lastly, the transportation facilities. The site selected for the hydroelectric plant must be accessible on transport facility, so that heavy machinery could be easily transported to the station. And these are the references that I have used, and thank you for listening.